Okay guys, so I'm doing my presentation on wind energy, Pythagoras and Leonardo da Vinci, and I hope you guys like it. My name is Angie Yamasaki from Cluster 3 of Cosmos at UC Davis, and we have a lot to talk about. So wind energy has been used since at least the 1st century AD, and as Kimberly said, Heron created the wind-powered organ using a piston to make wind come out of pipes, and then it has also been used to create rotational power for like extracting water and milling flour in the form of a windmill, and more recently electrical power in the form of a wind turbine. And yeah, this is an old windmill from like a couple hundred years ago, probably in Europe. And what else to talk about? So for wind, using wind energy, so there have been refinements in the design. So we have the post mill where the entire windmill rotated to a tower mill where only the cap rotated, but the bottom half was still made out of stone, and finally the smock where it got replaced by a wooden body, which saved on construction costs. And the first wind turbine was developed in Scotland by Professor James in 1887 in the summertime. And in the wintertime, we have a 12 kilowatt turbine created in Ohio by inventor Charles Bruss, which powered his estate for 20 years. And here's a map for the power generated by a wind turbine. We have kinetic energy 1/2 mv squared, m equals rho, which is density times value. Kinetic energy of wind, you substitute it in. Then you have delta value equals area times v, delta t, which is distance. And efficiency. So the theoretical efficiency of a wind turbine is at 59%, but realistically the most you can get is around 48% of a 3-bladed design, which creates an optimum amount of torque on a generator. And the average workload for a wind turbine is maximum offshore because of the wind at 48%. So the cost is still more than a conventional source, but the goal is to reach grid parity. And what is grid parity? It's when the cost is equal to the cost of conventional source, but a con of wind power is that it costs a lot of money to start up. The types of wind turbines. So we have National Renewable Energy Lab rates them from a ranking of 1 to 7 based on the amount of energy generated per area. And the usual form of a wind turbine is a ram air turbine mounted on a jet, which is used to create power for the gun. So the first type of wind turbine I'm going to talk about is called hot. Average blade length is around 60 to 130 feet, so it's pretty large. And the speed of the blade tips reaches 200 miles per hour and spins at 22 RPM. And they stop when the blades are feathered, which means they're like this instead of like flat against the wind. And here's a diagram. You can see how the wind is here, and then it turns. A gearbox connects with gears to a generator, and it turns in the wind using an anemometer, which calculates the wind direction. And it has a motor so it can turn to get the optimum performance. The blades are wide to create visibility for like aircraft and stuff, so we don't have an unfortunate accident. And yeah, they're usually deployed in groups to get like the maximum amount of wind power per, like in a valley where there's a high amount of wind because one isn't very efficient. And then here's a VAWT Darius. It was invented in 1931 by a French guy, and as you can see, instead of rotating like this, it rotates around like the central point right here. And a con of this is that it's like the materials, you can see it bends. It requires very expensive materials for it to work properly, and it needs like power to generate, to start turning on its own. However, it's mechanically simple because there's only like one moving part. And here's some variations like the Darius H and other stuff. So here's the Savonius. It was developed in 1924 by a Finnish guy, and the pro of this compared to like a hot turbine is that's very small, right? There's no big propeller to turn it. And as you can see, the wind goes in and it rotates in the opposite direction. And in the future, we have the airborne wind turbines will be tethered to the ground, and this will save on space, of course. And then, as you can see, the wind powers the turbine and it connects back to the ground into a transformer, and then it goes to the power grid. So the implementation of wind turbines actually began in California in the 1980s due to a tax credit which made it affordable, and then it spread to Europe where there's not a lot of like oil or natural gas, and then eventually it went around the world as the demand for renewable energy increased. And so here's the future of wind turbines. You can see like some conceptual designs, as you can see, maximizing efficiency and cost. And there's a large variety of options, a long history, and there's a capability for growth long into the future for wind turbines. So some criticisms of wind turbines, no system is perfect. Climate problems, it has been shown in studies that wind turbines can actually increase the temperature in the area in which they're built by a couple degrees because of the change in currents. However, the saving in CO2 emissions counteracts that. And then another Danger is bat strikes, like birds and bats crash into these turbines and then it can cause severe damage. Like a study showed that 600,000 bats were killed by wind turbines in the United States in 1 year alone. It's countered by having auto-stopping technology, which prevents the wind turbines from turning on when there's like birds are coming. The future, so as you can see, power plants are still the main kind of energy generation used in a lot of the world because it's cheap and it's easy to be available. And then so current records and achievements. In Denmark, they have 21% of their wind energy is sourced from turbines because there's not a lot of natural gas and oil. And they actually developed the largest wind turbine right here. And they use offshore, onshore wind turbine stuff. And then so the summary, this is a power plant in Monterey. It generates 2,400 megawatts. And the largest wind farm right now can only generate half of that. So there's still a lot of work to go. And that wind farm takes up a lot of space compared to the power plant. So there's still room for improvement. So thanks for watching that part. I kind of went too fast. It felt slower when I was practicing back at home. But now we're going to talk about Pythagoras and Leonardo da Vinci, two of the greatest minds that the world has ever known. So we'll start off with Pythagoras. His life is very unclear. There's no written records by him. And his society, the Pythagoreans, they always consider him like a god and a genius, so their reports are biased. And we're going to discuss his life, his religion, his Pythagorean theorem, and his death. So why his facts aren't clear? He created a religion called Pythagoreanism, which we'll talk about tomorrow. And it was very religious and was devoted to the worship of math and science combined. And he had a lot of followers. So he was born on a Greek island in 590 BC. His dad was a merchant and he got to travel a lot. And he moved in 535 BC to Egypt and he was captured by the Persians and eventually arrived at Babylon where he began his studies. So he developed of abstract theory and he studied mathematics. What part of mathematics? Like special kinds of numbers. The numbers where all the divisors, you add them up, it's equal to the number itself. Like 24, I think. And then here's just an example of abstract mathematics. It's not clearly defined. And his religion, there are two classes, mathematicoi and apusmaticoi. And mathematicoi focus more on the mathematical part, and they're the more strict, they couldn't eat beans because they thought beans were the symbol of life. And then this is the more religious part. So, numbers constitute all things. They believed in rebirth, kind of like Buddhism. They're ancient vegetarians, and they influence vegetarians today. And the bean code, they thought beans were the representation of life, right? So if you touch it, it might blow up or something, and you don't want that. So they don't eat beans. So Pythagorean continue. Here's some more code. Reality is mathematical in nature. Philosophy is spiritual purification. Here's just some more key parts of their idea. They're kind of a mystical group at the time. A lot of different religions around. This is their version. So here's a theorem. He wasn't the first one to know about this theorem. It was known by the ancient Indians and Babylonians, but he was the first one to prove the theorem. Here you can see side of the square is squared plus this square equals side of this bigger square squared. And you take the square root of that and you can get the individual thing, not the side length. And then he died, as everyone dies. They don't know exactly how he died. There's several rumors, but it is known that he died in Metaponum, Italy. It's not in great shape right now, but it's been many years since it was inhabited. And here's just a representation of him on a coin. And now here's Leonardo da Vinci. He's Italian. He's an illegitimate child. He's an artist. He designed stuff. He wrote in mirror writing, which is kind of an early form of code. You can see it here. It's kind of reverse, right? Like on a shirt in a mirror. It looks different. So, early life. There are two major moments in his early life that he recorded very significant to him. One, as a baby, he was touched by a kite on his forehead. He thought that was enlightening. And then here, he went into a dark cave, and he was both scared and excited to what could be within the cave. So, apprenticeship. At a young age, he became the apprentice of a guy named Verrocchio, who was a master Italian at the time, and he learned all aspects of humanities, crafting, painting, writing, art, chemistry, explosions, stuff like that. And then here's some of his artwork, and according to this, the portrait on the left is called Virgin of the Rocks, the portrait on the right is called Virgin and Child of St. Anne, and he also liked to dissect human bodies. That's where you get all those body sketches. So that's just a scalpel for representation. So here's Mona Lisa. He worked on it for 14 years. It was originally designed for a wealthy merchant of Venice, but he never finished it and decided to keep it for himself. And this is just a conspiracy theory. If you do some weird things to the picture, you get like a helmeted alien in the middle. And then he later died, but in later years he worked on mechanical projects like robots and stuff, which we'll talk about later. And he saw the rise of other greats of the Renaissance like Michelangelo. And he passed away on May 2nd, 1519 in France, and here is his tomb. So the tank, one of his early sketches. So it has multiple firing ports, so it can fire from 360 degrees. It combines speed to frighten enemy troops. You can see that now where instead of like tons of guns, just one gun that rotates on a turret. And as you can see the influence of Leonardo da Vinci's design. The submarine, he developed like, you can see his sketch propellers and aerodynamic shape. It kind of looks like a fist, and how now we have a streamlined hull. We have the engine in the back, like a little conning tower, and there's people inside operating the machine. So he was really a visionary as to what future technology could be, including the helicopter, the aerial screw, where people would run around in a circle and it would cause lift and it would just go up. And it's like the main rotor on a helicopter, but this, it just goes up. There's no need to counteract the torque generated by this, so it didn't need a tail rotor. And then robots. Who created robots? Not Michael Bay, but Leonardo da Vinci like 500 years ago. So, 1495 to 1515, he created robots with like special guests and stuff. So he has like a mechanical knife, mechanical dog, and you can see like the modern version of that in the army technology. So what to gain from all this? These guys, the thousands, hundreds of years ago, they didn't even have Facebook. So they knew stuff that we couldn't do without like four weeks of lessons from Professor Hafez. And we have wind energy and technology and future stuff, so there's a lot of stuff that we can gain from this. And here's a video about ancient aliens.
Oh boy.
It's not opening the hyperloop.
I think it holds shift or alt or something like that. It's like a Microsoft. It's all like.
I thought it was. No, it's just making it on our work. Yeah. Like anywhere.
Amazing inventions. Centuries ahead of their...
No, we're not watching all of it. We're gonna watch it the first like 30 seconds or a minute of it.
Amazing inventions. Centuries ahead of their time. The helicopter. The airplane. The submarine. All of these were Leonardo da Vinci's concepts. Paintings said to contain hidden messages.
It is only a portrait, and yet it seems to have dimensions and mysteries that have yet to be explained.
And sophisticated robots designed more than 5 centuries ago.
People would never have seen something like this that was able to move on its own.
Leonardo da Vinci is considered one of the most brilliant minds the world has ever known. But what was the source of his profound intellect?
He was absolutely immersed in finding out, maybe even proving, that we were not alone.
So there's a video. Thank you for watching, guys. Are there any questions?
No.
No? Okay.